In this class, I shall discuss the measurement of elasticity of demand. Here, DD is the demand curve. It is curve type, and in this demand curve, there may be so many points. Each point has certain slopes. At point A, I shall discuss here at point A measurement of elasticity. So, if we try to measure elasticity at that point, we should draw a tangent on that point. It will indicate slope of that point. So ST is the tangent on A point, and here price is OP and quantity is OQ1. Price is OP1 and quantity is OQ1. If we change price from P1 to P2, quantity will change from Q1 to Q2. That is, change in price is P1, P2, that means AB. Change in quantity is Q1, Q2, that means BC. In original curve, we see that C dash is there, and actually from A to C dash, this is the demand on that demand curve. But here we will discuss the elasticity of demand at point A only. Naturally, this slope at that point, that is the tangent, slope of this tangent, it will be discussed in elasticity aspect. Here C and C dash is supposed to be very close to each other. In fact, P1, P2 is not so much, which is seen here in the figure. It is very close to P1 and P2 is very close to each other. That is infinitely small change, but for our discussion, for our analysis, we have to show it in large form. For that reason, this gap has been erased. So now, elasticity of demand formula we know, E equal to dq by dp into p by q, delta q by delta p. Here delta q is this BC. Delta q means BC. Delta p means AB. BC by AB into original price OP1, that is OP1 is original price and OQ1 is original quantity. OQ1 is original quantity. So with respect to original quantity, we have to discuss. With respect to original price and original quantity, we have to measure elasticity. Now, measurement of elasticity can be shown in this form. Here, we find two triangles, ABC and AQ1T. Both the triangles, we have to discuss here elasticity at point A. Naturally, change should be discussed here. So, there are two triangles, ABC and AQ1T. Cone ABC equal to cone ABC equal to cone AQ1T. This is 90 degree. You see here, cone ABC equal to cone AQ1T, both are 90 degree. Again, we see here the cone, the angle BAC is the same angle in case of both the triangles, BAC and Q1AT. So, cone BAC equal to cone Q1AT, same angle. Last of all, there are right angle triangles, both are right angle triangles. The third angle should be same because other two are same. So, cone BCA will be equal to cone Q1TA. BCA will be equal to cone Q1TA. It is remaining cone. So, triangles are equiangular. And sides are proportional. Triangles equiangular and sides are proportional. So, we can here simply discuss according to the geometrical proof as sides are proportional, so BC by AB will be equal to Q1T by AQ1. Here BC by AB will be equal to Q1T by AQ1. Q1T by AQ1. Base by vertical equal to base by vertical. Now if we put this Q1T by AQ1 on the formula, then we will get E equal to Q1T by AQ1, Q1T by AQ1 into OP1 by OQ1. As because AQ1 equal to OP1, AQ1 equal to OP1. This is simply shown in the figure. AQ1 equal to OP1. So we can again write down Q1T by OP1 into OP1 by OQ1. In this way, elasticity equal to Q1T by OQ1. But elasticity here, we proved it that elasticity equal to Q1T by OQ1. But we are measuring elasticity at point A, not at point Q1. So here if we draw a perpendicular from the base Q1 point, it will bisect the hypotenuse as it bisects the base. Now here we get two triangles, AQ1T and SP1A, AQ1T and SP1A. In triangles, AQ1T and SP1A, cone AQ1T equal to cone SP1A, as both are right angle triangle, 90-degree angle, right angle triangles. Again, cone AQ1T and SP1. Again, cone Q1AT equal to cone P1SA. Q1AT equal to cone P1SA, because they are similar angle. Similar angle means this type of angle, they are called similar angle. Here this angle and this angle are similar angle. Again, both the triangles are right angle triangles. Naturally, their third angle will be same. In that case, cone Q1TA equal to cone P1SA. P1SA. I'm sorry. P1AS. P1AS. Q1TA equal to P1AS. They are remaining angle. So triangles are equiangular and sides are proportional. Here we can say it that the sides will be proportional for that base by base equal to vertical by vertical equal to hypotenuse by hypotenuse. As both the triangles are same and equiangular, now we can easily conclude that base of one angle by base of another equal to vertical by one angle, vertical by other equal to hypotenuse by hypotenuse of another angle. So from that point of view, we can here say that the formula will be such that equal to Q1 T by OQ1, Q1 T by OQ1 equal to AT by AS. As because Q1T equal to Q1T by OQ1. Again, OQ1 equal to P1A. So equal to Q1T by P1A equal to AQ1 by SP1 equal to AT by AS. So elasticity at point A will be lower segment of that point by upper segment of that point, AT by AS. This is the elasticity. We measure here elasticity at any straight line demand curve. Elasticity will be lower segment of that point divided by upper segment of that point, lower segment by upper segment. Here, if the demand curve is such that at point A, elasticity will be AT by AS, AT by AS. As AT equal to AS, AT equal to AS. So if we shift it from this point to that point AS, then it will be 1. Again, at point B equal to BT by BS. As BT less than BS, you see here BT less than BS, BT less than BS, therefore BT by BS will be less than 1. Again, at C point equal to CT by CS, as CT less than, CT greater than CS, then CT by CS greater than 1. Likewise, at point S equal to ST, lower part ST and upper part 0, ST by 0 equal to infinity. Here equal to lower part 0 but upper part TS, then it is equal to 0. 0 by something equal to 0. So elasticity varies between 0 and infinity on a straight line demand curve. In midpoint, it will be elasticity will be equal to 1. Lower part, it will be less than 1, and in upper part, it will be greater than 1.